Welcome to my quick version of the unit circle. In this video I'm going to go through all the points, degrees, and radians of the unit circle and give you basically just a quick video version that you can learn to kind of memorize the unit circle from. In a subsequent video I'll go back and I'll actually derive and show you where some of these values are coming from, and from there I'll make separate videos on the values, the trig function values at all of these degrees, and we'll go from there. But really quickly here, let's just set this up. Right, the unit circle itself is something that is incredibly important in trigonometry. Right, we're going to use it a lot. The radius of this circle is 1. That's why we call it the unit circle. So that distance is 1. Right, this distance is 1. This distance is 1. This distance is 1, all the way around. So this point is 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. Those are your basic sort of north, south, east, and west points. I'm going to put all my degrees in red and all my radians in green. Here at this point we are at 0 degrees or 360 degrees. Right? So if you went here, it's 0 degrees, but you can also spin all the way around and come back and be at 360 degrees. In terms of radians, the radians will be 0 radians or 2 pi radians. Yep, a full revolution of a circle is 2 pi radians. If we extend our angle, so we start here and we extend it up this way, we have 30 degrees right here. And 30 degrees is going to be open to this point. That point is on the terminal side of this 30-degree angle. And those values right there are radical 3 over 2 and 1/2. So that's 30 degrees. And in terms of radians, if you wanted to convert that, you'd see that it's pi over 6 radians. And again, later on I'll explain where I got these two numbers from. But in this video I'm not going to do that. As we move along, we encounter this point right here. Alright, that point is on the terminal side of a 45-degree angle. 45-degree angle will create a triangle that's isosceles and right. And this is radical 2 over 2, radical 2 over 2. Those values are coming from the fact that our hypotenuse is 1. So that's at 45 degrees and pi over 4 radians. As we move along, we encounter a 60-degree angle right here. So this angle would be 60 degrees. So this point lies on the terminal side of that 60-degree angle. And that's basically going to be the opposite of this one right here. You take the x and the y and you kind of switch them, just like you would do for maybe like an inverse or something like that. So now it's going over 1/2 and up radical 3 over 2. Radical 3 over 2 is roughly equal to 0.866. Alright, so those are the basics. Then we encounter 90 degrees, right? A 90-degree angle is right here. And at 90 degrees we have pi over 2 radians. Pi over 2 radians. Let me finish this one. This is 60 degrees and pi over 3 radians. So that's quadrant 1 right there. Those are the basics. As we move along, we're just kind of like opening our angle up a little bit more. So now we have an angle that is this big. So it's 90 plus 30. 90 plus 30 is 120. So I'll put that in red. This is 120 degrees. And it's sort of right across from pi over 3. It's 2 pi over 3. And those values are exactly the same as they are over here, except just negate the x value. Because you're going from the origin to right here, so that's -1/2. The hypotenuse is still 1, and this is up radical 3 over 2. So there's your right triangle. And this right here would be 120 degrees, meaning this would be 60 degrees. And again, I'll get more into that in a different video, but let's move on. Next one we encounter is in the 45 degree family. If this is 45 degrees, right, and this is 90, then this is 135. It's 90 plus 45. That's 135 degrees. And it's 3 pi over 4. Those values mimic these values, except negate the x. Next up is right here. All right, this point is right across from here. So we're going to go negative root 3 over 2 and positive 1/2. This is in the 30 degree family. So if we went 30 degrees, we would see, okay, here's 30, that's pi over 6. This is 2 pi over 6. This is 3 pi over 6. This is 4 pi over 6. So this is 5 pi over 6. That's how we get that. And that would be, in terms of degrees, it would be 90 degrees plus 60. 90 plus 60 is 150. And it's 30 degrees from 180. It's a different way of looking at it. Alright, so notice the nice symmetry we have, you know, as we go across the unit circle. These points are very close to each other. The x's are just negated. These points are very symmetrical. These points are very symmetrical. All right, the symmetry is going to extend down this way too, which is nice. A lot of these same x and y values are going to appear again. So here we have 180 degrees and pi radians. 180 degrees is equal to pi radians. So if we continue along our unit circle, we encounter this point right here. So this is, let's see, 180 plus another 30. So that's 210. So this is 210 degrees. And if this right here is 30 degrees, that's pi over 6. So what I want to do is take pi over 6 and add it. I want to take pi over 6 and add it to pi, because pi is 180, and I want to add another pi over 6. Well, that's just 7 pi over 6 then. And those values are going to mimic the values above. So we're going to go negative radical 3 over 2, negative 1/2. Moving along, we're down here. This is in the 45 degree family, so it's going to be 180 degrees plus another 45. So 180 plus 45 is 225. And this is in the pi over 4 family. So here's where we're getting that from. We're saying, okay, pi over 4, 2 pi over 4, it simplifies to pi over 2. 3 pi over 4, 4 pi over 4, 5 pi over 4. That's where those come from. Because this is actually 4 pi over 4, and if you add another pi over 4, it's 5 pi over 4. So those values are going to mimic these values and mimic these values. All the pi over 4 values are essentially the same. Just have to be careful with the signs. In quadrant 3, everything is negative, both x and y values. Alright, so we're seeing some symmetry. Moving along, I've got my next angle, so it starts here and goes all the way around to here. So it's 180 plus, this is 60 degrees. So 180 plus 60 is 240. 240. And this is in the pi over 3 family. So I've got 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So those values are going to mimic the other pi over 3 values. So if I sort of look straight up here and match these up, it's negative 1/2 negative radical 3 over 2. Down at the bottom of our unit circle, we're dealing with 270 degrees, which is 3 pi over 2 radians. Next up, we encounter this guy. So this is, let's see, it's 270 plus another 30. That's 30 degrees. So this is going to be 300 degrees. And 300 degrees, this is going to be in the pi over 3 family. So we're dealing with, you know, if we keep track here, let's zoom back up a little bit. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So it kind of helps sometimes to go around like that. And that was radians, 5 pi over 3. So those values, the x and the y value there, are going to mimic the other ones. Just negate the y value this time. Keep the x positive, negate the y value. Here we have a family in the 45 degree family. So we have, let's see, from here all the way over to here. So that's 270 plus 45. 270 plus 45, that's 315. And in terms of radians, watch how easy this is. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And those values are going to mimic the other pi over 4 values. Radical 2 over 2, negative radical 2 over 2. And we're almost done. We have one more. So our last value, you can see, is nice and symmetrical with that. So we're going to be radical 3 over 2, negative 1/2. So this is in the 30 degree family. It's basically, it's 30 degrees away from 360, so it's 330 degrees. And in terms of radians, watch this. Pi over 6, 2 pi over 6. It's actually pi over 3, but think about what pi over 3 is. 2 pi over 6 is pi over 3. So I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So there you go. There's the sort of the basic, bare bones introduction to the unit circle. A lot of stuff to know, a lot of stuff going on. We're going to definitely use this a lot, though, as we, you know, like I said earlier, as we start to think about, you know, the sine of 300 degrees or the cosine of 225, or, you know, even like the tangent of 390 degrees or something like that. Like if we have something that goes around, and then it comes all the way back around. All right, so it's 360 plus this 30 degree angle. So we'll talk more about reference angles. In my extended unit circle video, I'm going to tell you more about the fact that this is 1, this is 30. Where on earth do we get radical 3 over 2, or 1/2? All right, we'll go into that in our next video. But, I mean, in terms of symmetries, check this out, right? We have nice symmetries here. This is across from this, and their values basically match up. And then we can take that down to here. Look at the values here and here. They basically match up. We can take it over to here. Those values match up. And back up to here. Those values match up. So everything that's yellow right now, the values, the x and y values, are essentially matching up with subtle differences in the plus and minus. But if you look at the 45 degree family, right, that creates a nice square. So all those values are radical 2 over 2. So all the pi over 3 values are up here. All the pi over 4 values look like that. All the pi over 6 values look like that. So the pi over 6 values match up as well. And they all have generally the same idea. All right, so the symmetry is what you want to really sort of latch onto and really get good at. All right, this is 0, 1, 2, 3, 4. That would be radical 4 over 2. So there you go. Any way you can memorize that is awesome. We're going to get into much more detail later on, and we'll do that in the subsequent video, and then really I'll continue to expand my trig portfolio. But I think that's pretty good for now. The short version is about 15.5 minutes, so the longer version is going to be quite a bit longer than that. But I'm going to keep all these values up here for my next video, so we don't have to revisit all of those things. But thanks for watching, and I'll see you in the next one.